One of the things you'll discover just a little bit later in the tutorial is that nothing really happens until you start a ticker and tell the world to render on every timer tick. So what's interesting about this code is that it's not really obvious where to place this. In fact, on my first iteration of the integration, I had decided to create a ticker service, but now I'm deciding to throw that out. What this code really represents is post-initialization code for our physics canvas. Every time I have a physics canvas, yes, I want to set up a world, I want to wire it to a canvas element, but I also just want this ticker and world rendering to be kicked off automatically. It's kind of interesting because there's not many places where you can find a good example of using pre and post linking functions in Angular, but setting up this timer is a pretty good example. I want to have a pre-linking function on my directive to make sure this parent is ready to go for any child directives. It has the world created, and it has the ability to allow bodies to be added to this world. But then once all of that is done, I want some initialization code to run and set up this timer tick. And that's almost ideally what post linking is for, because with a post link, the parent runs last. Now, in addition to pre, I'm also going to have a post link function. And instead of using an anonymous function here, let's come up and write it here. Post link is a function, and just like a pre-linking function, this can take scope, element, attributes, and controller. But all I really need here is just scope, because scope will give me access to the world, and that's all I need to do to set up this timer. Well, that and the physics service, because I need to tell the physics service to set up an event handler on the ticker so that every time it ticks, it will call this function and pass in the time, and I will tell my world to step to that time, basically go to the next frame, and again, pretty much just copying this initialization code verbatim with the exception of adding scope. The next piece the tutorial shows is wiring up a step event on the world, and what you do on every step is tell the world to render, and then finally we'll do a physics.util.ticker.start, and that should set the world in motion, because remember when we created these two little blocks here, I gave them some initial velocities. Maybe I can decrease that just a little bit. I will suspect that they will float upward since they have a negative y velocity. I've saved everything. Let's come back to the browser. This is where the application loads. Let's refresh this. And there I can see the floating blocks. So before we review what we've done, let's add a couple more features to simulate gravity and boundaries.